welcome to my channel. And this is Veral Tafreshi today with a new video. In this video we're going to talk about the most important device in our environment, corporate environment, that is the network switch, right? So uh, what is a switch? I would say the switch is the most important and essential building block that you will use for the network, right? And mm, this switch is actually the central point of connection, right, for the devices which is plugged into the network. So so just imagine that you have a building, right? You have an office. So you have an office, say a floor, right? You have a floor and you have cubicles over the floor, right? You have multiple cubicles. You have the rooms, conference rooms. You have some uh, uh, private cabins over there. And then ultimately what happens is you need jacks on these cubicles, right? You will have those wall jacks where the ethernet port comes in, right? So those ethernet ports cables will run through your ceilings, your walls, right? And then it will ultimately lead to a room that is called the MDF. MDF, right? MDF. And there actually you have a rack. Wherein you have these devices racked up, right? You have switches, you have mm, the firewalls, we have the routers and all those devices. So what happens is these cables that run to your desk, they will come in back to MDF, and these will be plugged into your what do you say, your switch ports. It will be literally connected to these ports, right? These, right? So that is the switch. And the switch can be an L2 as well as it can be an L3. So what does that mean? You would know the OSI layer, right? OSI layer in open system interconnect model, right? You have the layers: layer 1, layer 2, layer 3, right? So layer 2 would be your this data link layer, right? Data link layer. So the devices that work on the data link layer are called L2 devices. So these devices will work on the MAC addresses. So, and the next is the L3 devices. So on top of L2, the data link layer, you have the network layer, right? Network layer. And these devices can understand the addressing scheme that is called the IP address. So these are the L3 devices. So you have switches that can only understand the MAC addresses, and you have also switches that can understand the IP address as well as the MAC address. So this is the basic idea of a switch that you use in your network to connect the devices in your LAN segment. So guys, that's what the switch is. And actually this is the third generation of device. This is the third generation device. What do I mean by that? So the first generation would be so I'll just write it down here. First generation would be a hub. You might have heard about hub. And what it was like, it was a dumb device that will repeat the signals. That's it. So for example, we say that this is a hub. The first switch is a hub, right? This one, say, just so we have a device here, a computer PC over here connected, and we have a server here. Okay, we have a server here connected, and also we have multiple devices connected into this hub. So what will happen is when this device A wants to communicate to another device B, so for example it will send the traffic to this port. What this hub would do is it will send the data through all the ports, including the port where the server is, or even when someone is communicating to the server, right? So everybody else would get that traffic. So think about it, guys. It was a big problem. Problem one was that it was a big security issue, right? So security was the one issue. So because it's just think there is a guy here, a malicious guy in our LAN, and he is running a sniffer like you can say you have Wireshark, right? You can run a Wireshark, and he can capture all the data on the LAN segment, right? On the LAN segment, and he can know, he can just see what is happening in between this PC and this server. So that was a big security problem. Second was it was a single broadcast domain. What does that mean? That means is when one guy is talking to another device, right? One device is talking on a device, all other devices are getting disturbed. They will receive the data whether they want or they don't want, right? So that was the second issue. Then came the second generation was a bridge. It was a bridge. Okay, let me just clear this thing. Let me just clear this erase, delete this. Okay, so the first generation would be hub, and the second generation is a bridge. Okay, what was a bridge? Bridge was an intelligent device as compared to an hub. It was a device where it could learn the MAC addresses. So for example, say you have PC1 here, and it sends the traffic to this port. This device, if it was a bridge, would learn the MAC address on that port. Say port 1, you have connected a MAC address of say 001A, and then 002B, and FCEA, so something like that. So the MAC address is actually 48-bit long, and it's 12 digits. So you can also write MAC address like this. So it will be like this, okay? FCE. So if I take this eraser, say let's see this one, and I'll go with this FC and EA. So this could be the MAC address, right? So this this bridge would learn the MAC address here, and say for example we have the server on this port, and it will learn the MAC address of the server also. So say the server address is 00 A 012 34 AB, whatever, something like that. Okay, so this is not 12 digits, so FC. So for example, this is the MAC address of the server. So when this port, this PC wants to communicate to the server, right? Now if it was a bridge, so the bridge will receive the frame on his port, and it will know exactly where this server is, and it will directly send the frame to this port, right, without disturbing others on the segment. So next, the third generation would be our switch, right? So what is the difference between a switch and a bridge? The major difference is that the bridge is actually software based. What do you mean by that? The thing is that it was built in a software environment, so that would take a lot of time. It will take up a lot of processing, the bridge, while as the switch was built with hardware. So somebody came up and thought, why not build this software into hardware, because the hardware could transmit at the speed of the wire, right? So they developed a technology called ASICs, and the ASICs are the main main part uh, of the switch, the third generation switch. So these switches are hardware based devices which use the hardware called ASICs. And what does that ASIC stand for? And the ASIC would stand for application specific integrated circuitry, right? So that is uh, uh, the term that is used for ASICs. And so that is what ASIC stands for. And then the difference between a bridge and a switch is that the bridge uses the software, but the switch is using the hardware. So you can say that a switch, the third generation switch, is a combination of a hub and a bridge. It is as fast as a hub and it is as intelligent as a bridge. So the switch can move the frames at a wire speed, as well as it can learn the MAC addresses that are coming on to the ports, right? But then again, there is a drawback, and the drawback would be, just tell me guys, what is important, what is easy to upgrade, the hardware or the software, right? Can anyone tell me? uh, I would assume the answer would be software, right? Because you can just download a package and just install the latest package into your hardware. But the hardware, if you want to go and upgrade the hardware, then you need to change the whole switch, right? You need to change the whole device itself, or the module that you want to upgrade. That is the drawback in case of this switch. But then again, this hardware based switch is not an intelligent as a software based device. But then again, these are very intelligent nowadays. They are loaded with so many features. But I'll again say that they are not intelligent as a software based device. And you will come to know this in my next videos, why I'm saying you that. And guys, these devices are typically 24 to 48 ports, typically I'm saying. But nowadays you will have the big large switches, like module based switches, that you have in Cisco, as well as in other vendors as HP and Cisco, right? So Cisco, you have the Nexus switches, and HP, you have the Aruba switches, the 5400 series switches, which are the chassis based switches with different modules. But the switches that have typically 24 to 48 ports, you can just connect them in a daisy chain to gain more ports. Like this, you would connect them into what do you say, stack. The technology is called stacking, and it will appear that this is a single body with so many ports. So that is the overview of the switch. And this would be all for this video, and hope to see you again in my next video, in which I'll be giving you an overview of the routers, that is the L3 devices. Thank you very much.